Welcome to the session of mathematics. In today's session, we will solve few problems on binomial expansion. Before that, we will see some results. We know the formula for NCR, that is number of combinations taken R at a time. NCR is equal to factorial n upon factorial n minus R into factorial R. Based on this formula, we will derive some relations. N is equal to how much? By this formula, it is factorial n upon factorial n minus value of R here is n. N factorial into factorial n. It is equal to factorial n upon this bracket 0 factorial, and 0 factorial is 1. Therefore, the final answer is 1. Now let's see what is LC1. NC1 is equal to factorial n upon value of R here is 1. Therefore, n minus 1 factorial into R factorial, that is 1 factorial, is equal to this. N factorial can be written as n into n minus 1 factorial upon n minus 1 factorial into 1 factorial is 1. This bracket gets cancelled and the answer is n. Therefore, NC1 is equal to n. NCn is equal to 1. Now let's see what is NC0. NC0 is equal to factorial n upon, here value of R is 0. Therefore, n minus 0 factorial into 0 factorial. Therefore, n factorial upon n factorial into factorial 0 is 1. Therefore, the final answer is 1. Therefore, NC0 is equal to 1. These are the three basic results which we will use in the expansion of the given binomial. Now let's solve this problem. Here we are asked to find the expansion of x minus 1 by x whole raised to 6. As here value of n is 6, the expansion of this will be consisting of 7 terms, that is n plus 1 terms. Here value of a, that is first term, is x. Value of b, second term, is equal to minus 1 by x, and value of n is equal to 6. By using binomial expansion, we can write x minus 1 by x whole raised to 6 is equal to NC0, that is 6C0 a raised to n x raised to 6 b raised to 0. Value of b is minus 1 by x raised to 0 plus NC1, that is 6C1 a raised to n minus 1. It will be x raised to 5 into b raised to 1. Value of b is 1 minus 1 by x raised to 1. Addition of these two indices, it will be always equal to n, that is 6 plus 0 is equal to 6, 5 plus 1 is equal to 6. We have to decrease this index by 1 and increase this index by 1. Now next term will be 6C2 x raised to 4 minus 1 by x raised to 2 plus 6C3 x raised to 3 into minus 1 by x raised to 3. Next term is 6C4 x raised to 2 into minus 1 by x raised to 4. Addition of these two terms is 6. 6C5 x raised to 1 into minus 1 by x raised to 5. And last term is 6C6 x raised to 0 into b raised to n. 6. 1, 2, 3, 4, 5, 6 and 7. N plus 1 terms will be there in the expansion of this binomial. Now, as we know, 6C0 is 1 into x raised to 6, anything raised to 0 is 1. Therefore, first term will be just x raised to 6 only. 6c1 is 6 x raised to 5. As this power is odd, this will be negative value minus 1 by x plus factorial 6 NCR, factorial n upon factorial n minus r into factorial r. Therefore, factorial 6 upon 6 minus 2, value of r here is 2. 6 minus 2 is 4 factorial into factorial r, which is factorial 2 into x raised to 4. As this is square term, this will be the result will be the positive into 1 by x square plus factorial 6 upon 6 minus 3 factorial is 3 factorial into r factorial is 3 factorial x cube. As this power is odd, this will be minus value 1 upon x cube. We can write in this fashion. Plus factorial 6 upon 6 minus 4 factorial 2 into factorial 4 into x square. As power is even, we can write this as x raised to 4. This term will be positive because this power is even. Plus factorial 6 upon 6 minus 5, it is factorial 1 into factorial 5 into x raised to 1. This power is odd, therefore we can write this is 1 upon x raised to 5. The result is negative because this power is odd. Now NCN is again 1. NC 0 and NCN, both values are same, that is n. Sorry, there is 1. 6C6, its value is 1. X raised to 0 is 1. As this power is even, we can write this as 1 by x raised to 6. Let us simplify this. The first term is x raised to 6. Second term will be minus. We will get alternate plus and minus terms. Here minus 6 x raised to 5 by x is x raised to 4. Here 6 factorial 6 can be written as 6 into 5 into factorial 4 upon factorial 4 into 2 into 1. X raised to 4 upon x square is x square plus factorial 6 can be written as 6 into 5 into 4 into factorial 3 upon factorial 3 into 3 into 2 into 1. This will get cancelled. This will be the minus term. Next term is plus factorial 6 can be written as 6 into 5 into factorial 4 upon factorial 2 into 2 can be written as 2 into 1 into factorial 4. This will be cancelled. X square upon x raised to 4 is 1 upon x square. Next term is factorial 6 can be written as 6 into factorial 5 upon 1 factorial is 1. 5 factorial will get cancelled. X raised to 1 upon x raised to 5. It will be 1 by x raised to 4. As this is negative term, we have to take here minus sign, and the last term will be positive plus 1 by x raised to 6. The final answer will be x minus 1 by x whole raised to 6 is equal to x raised to 6 minus 6x raised to 4 plus 6 5s are 30 upon 2. It is 15. 15 x raised to 2 minus, here 3 factorial will get cancelled. 3 2s are 6, 5 4s are 20, minus 20 plus, next term is 6 5s are 30, 30 upon 2 is 15, 15 upon x square minus 6 by x raised to 4, 6 by x raised to 4, and the last term is 1 by x raised to 6. 1 2 3 4 5 6 7. There will be n plus 1 terms, that is 7 terms in the expansion of this given binomial. Now let us solve few problems on binomial expansion by using the formula for general term. The formula for general term, that is TR plus 1 is equal to NCR a raised to n minus r into b raised to r. TR plus 1 is equal to NCR into a raised to n minus r into b raised to r. Here, for the expansion of this x minus 1 by x whole raised to 6, here first term is a is equal to x. This is the first term. Second term is b is equal to minus 1 by x, and this index n is equal to 6. Suppose if we are asked to find fourth term of the expansion, we need not to go for complete expansion. Instead, we can use this formula to find the required term. We want to find fourth term, that is T4 is equal to, this can be written in this r plus 1 form, T3 plus 1 is equal to NCR, value of n is 6, 6C, value of r is 3, 6C3, a raised to n minus r, value of a is x, x raised to, value of n is 6 minus r value is 3 into value of b, b raised to r, b is minus 1 by x raised to r, r value is 3. Now 6C3 can be written as 6 factorial upon n minus r factorial, that is 6 minus 3 factorial into 3 factorial into x raised to 3. As this power is odd, we will get negative sign. This is 1 by x raised to 3. This will get cancelled. Factorial 6 can be written as 6 into 5 into 4 into factorial 3 upon 6 minus 3 factorial is 3 factorial, and factorial 3 can be written as 3 into 2 into 1, and into the left out thing is just 1. Now here we can cancel this 3 factorial from the numerator and denominator, and 3 2s are 6. The final answer is 5 4s are 20 minus 20. This is the fourth term, required term. See here. See, from this expansion, term number 1, 2, 3, 4. This is the fourth term. We do not go for complete expansion. Instead, we can use the general term formula and find the required term. Now, how to find term independent of x? Means, in the expansion of this binomial, there exists one term which is free from x. For that, let us again assume the TR plus 1th term is the term independent from x. And after equating the overall index of x to 0, we will get the term independent of x. Therefore, let us write TR plus 1 is equal to NCR a raised to n minus r into b raised to r. Here value of n is 6CR, value of a is x, value of n is 6 minus r, value of b is minus 1 by x raised to r. 6cr x raised to 6 minus r into 1 by x raised to r into minus 1 raised to r. I have separated 1 by x and minus 1 to avoid the confusion. If we get this value of r odd, then this term will be negative, and if we get this value of r even, then we will get this as a positive. Therefore 6cr, collecting all the powers of x and applying the indices rule, will get x raised to 6 minus r into minus 1 raised to r. This is 6cr into x raised to 6 minus 2r into minus 1 raised to r. Now let us equate this power equal to 0 to get the term independent from x. Therefore 6 minus 2r is equal to 0. This implies r is equal to 3. By putting value of r here 3, we will get the term independent of x, that will be t fourth term, because 3 plus 1, r plus 1 term is a independent term. 3 plus 1, that is t fourth term. Fourth term will be the term independent of x. Therefore t3 plus 1 is equal to t4 is equal to ncr, that is 6c3 a raised to r x raised to 3 into a raised to n minus r 6 minus 3 into b raised to r, that is minus 1 by x raised to 3, putting value of n and r. This can be written as factorial 6 upon 6 minus 3 factorial, that is 3 factorial into r factorial into x raised to 3. As this power is odd, here we will take negative sign into 1 by x raised to 3. This x raised to 3 will cancel, and this factorial 6 can be written as 6 into 5 into 4 into factorial 3 upon factorial 3, and into this 3 factorial can be written as 3 into 2 into 1. This 3 factorial from numerator and denominator will get cancelled. 3 2s are 6, 5 4s are 20. This is the minus 20. This is the term independent of x. Actually, we can solve all such problems by using formula for general term. We need not to go for complete expansion, but for easy understanding or for reference, I have taken the previous problem solution for validating or confirming the results.